Okay, so welcome to Mr. Mack's online chemistry class. Today we're going to learn how to draw ionic bonds. And to do that you need to know a couple of things. You need to know the elements you're working with, the number of protons in each element, number of electrons in each element, number of valence electrons in the outermost orbital, and the oxidation number, which is another name for the charge of the ion. So you're going to need your periodic table to do this also. So our first element here is lithium. So let's find lithium in the periodic table, and you can see that it's right here. Its atomic number is 3, which tells us it has 3 protons. It also has 3 electrons, and it's got 1 valence electron. So let's go back and fill that information in. 3 protons. It's got 3 electrons. 1 valence electron. Now remember that if an element is a metal and it's got 1 valence electron, it's going to want to get rid of that valence electron. And when it loses an electron, its charge is going to become positive. This is actually going to become a +1 ion, because now it's going to have more protons than electrons when it loses that 1 electron. So let's go back and find nitrogen now. You can see nitrogen's over here in group 15. It's got 7 protons. We know that because the atomic number is 7. 7 electrons, and its valence shell has 5 electrons. So let's go back and fill in our chart. So nitrogen has 7 protons, which also means it has 7 electrons. Number of valence electrons is 5. So nitrogen is going to need 3 more electrons to fill its valence shell. So if it gains 3 electrons, it will then have more negative electrons or particles than protons, and that will become a 3- charge. So its oxidation number would be 3-. Okay, let's go fill in potassium. Let's go back to our periodic table. Potassium's atomic number 19, and it's got 1 valence electron. So it's got 19 protons, 19 electrons. It's got 1 valence electron, which means it also will become a 1+ charge. Okay, and our last element here we want to look at is sulfur. So let's go back to our periodic table. Sulfur's way over here in group 16. It's also atomic number 16, and it has 6 valence electrons. 16 protons, 16 electrons, 6 valence electrons, which means it's going to gain 2 electrons to fill its valence shell or octet, so it's going to become a 2- charge when it does that. So its oxidation number is 2-. So now that we know all this information, we can go and we can begin to write chemical formulas. So the first one we want to demonstrate here is lithium nitride. So lithium nitride contains the element lithium, also the element nitrogen, right? And after you write in the atomic symbols, what we want to do is we want to put the oxidation numbers above each symbol. So we know that lithium is a 1+ charge. I'm going to write that as a superscript. And we know that nitrogen, according to our list here, is a 3- charge. Okay, now you learned in class that the overall, even though this molecule is made up of charged atoms, the overall charge of the molecule has to be neutral. So what you have to do is you have to look at your exponents here, or your superscripts, right? If this is a 3 minus, we want to make this lithium cancel out nitrogen ions. So we would have to go back here and we'd have to put 3 atoms of lithium. So now when we do our math, 3 times 1 is 3, and then you have negative 3 over here, so these ions all cancel each other out. So our final chemical formula is going to look like this. It would be Li3N. And this is how we would properly write it, like this. Okay, and we're done with that one. So the proper chemical formula for lithium nitride would be Li3N, 3 atoms of lithium and 1 atom of nitrogen. Let's do one more. We have potassium sulfide. So that's going to contain the element potassium, which is atomic symbol K. And the atomic symbol for sulfur is S. So the next thing we want to do here is we want to put our oxidation numbers in. And according to our list, potassium is a 1 plus charge. Sulfur is a 2 minus charge. And we're going to make these superscripts. And as you can see by looking at this formula, that it's not neutral. We have a 2 negative charge here and a 1 plus charge here. So we have to make this 1 plus cancel out this 2 negative. And the way we're going to do that is we're going to put 2 atoms of potassium in here. So our final chemical formula is going to look like this. It's going to be K2S. So one molecule of potassium sulfide, its chemical formula would be K2S. 2 atoms of potassium and 1 atom of sulfur. And that's how you do ionic bonding and figure out how to write chemical formulas for ionic bonds.